Greetings and welcome. Hey, guys, internet friends, I'm going to include you in on this little exploration. You will be our partners, and unfortunately, we're not watching this video in real time. I can't check my chat channel to, see if you're getting along with this. So I guess me and my friends in real life will do most of the heavy lifting. But if you wanted to pause this, you could follow along. You could give it a try with maybe a friend sitting at a lunch table with you as you're watching math videos on YouTube, as the kids love to do these days. So here's exploration one. We're talking about, by the way, point slope form. We're gonna discover a new form of the equation of a line. This is gonna go Super Saiyan, friends. This is like Charmander becoming Charizard, like, right? Charmander being, I don't know, standard form AX plus BY equals C. And then like Charmeleon was probably the inner stage, which, by the way, my 5-year-old son Everett just had his Charmander evolve into a Charmeleon this morning. He was pumped. He was pumped. He got his first dragon move as well. And then like point slope form, this new form we're going to discover is going to be Charizard. It's going to be Charizard up in here, friends. Look out. It's going to be the most powerful form. Oh my goodness. Okay, here we go. I'm a little excited. So here it says, sketch the line that has the given sloppy and passes through the given point. All right, so M is a half. All right. And here's a point. If I want to find more points on this line, how do I move by my slope to find another point? Up one, and then where? Over, the run is 2. Up 1 over 2. Up 1 over 2. And up 1 and over 2. And then I could draw my line. All right. Let's see, connecting my dots. Right there we go. So there's the line that I would get, something like that. Now it asks a question. It says, find the y-intercept of that line. Does anyone have a guess on the y-intercept of that?
The y-axis.
Yeah, what number do you think it hits the y-axis at? Well, if this is 0, here's 1. 1.5 would have been right here. Another guess? Yeah, probably just a half, yeah. So 0.5 or 1/2. It looks like the y-intercept was a half, which if I was writing in slope-intercept form, this is what I would have had. I would have had y equals 1/2 x plus a half. All right? And we've been awesome with slopes that are fractions because, yeah, it's easy. Up 1 over 2, up 1 over 2. But a y-intercept that's a fraction is kind of inconvenient. Because, like, if I wanted to go up 1 over 2 from here, I would have landed, like, all right, now I'm at 1.5 and then over 2. Yeah, I would have like landed at all of these weird half points. Oh, man. Right? And I would have been like offset the whole time. This line would have ruined my day. But we're going to teach you the more powerful form today. It's going to be great. Let's look at part B. So the slope is -2. So to move from this point, I'd go down 2. And then where do I go? Yeah, because there's that little invisible 1 hiding there. Over 1. Right? Down 2 and over 1. Down 2, we're having fun. Down 2 and over 1. Draw a line all the time. Walk. Yeah, feel free to, you can download this YouTube video and as an MP3, edit out just that portion of that song, and you can listen to it on loop forever if you'd like, while you're doing your math problems, or when you're like jogging through the woods, or playing Pokemon Go. I don't know, whatever. Feel free. No royalties on that song. Royalty-free song. You're welcome, internet. So let's see. What does the y-intercept appear to be for this line? Yeah, this one at least hit the grid. It looks like b equals negative dose. Our y-intercept, our slope was given to us. M was equal to -2. So what would the equation of this one been?
Y equals
Yeah, plus -2, but I'll simplify that to be -2. These problems are actually a little bit weird, where they both coincidentally had the same slope and y-intercept. Like, that's bizarre. Like, that almost doesn't make this as helpful as an example. That was completely coincidental. That was not the point that we were supposed to get. The point that we were supposed to get is that sometimes there's a form out there that's helpful for finding lines. Oh wow, this is going to be great. It's called point slope form when I have a line that doesn't pass through the y-axis at a wonderful place. Now, the second equation we had here, we could have graphed that just dandy. But point slope form, get ready for this. It's amazing. I'm pumped. Is this right here? Maybe someday I'll derive this for you guys, but right now, we're just going to jump right in. So point slope form, all right, is this. Instead of y equals mx plus b, it is, I'll write my own, y minus y1 equals m parentheses x minus x1. And the things that I would plug in, I would still need the slope, and then I would need my y1 and x1, where x1, y1 happens to be a point that my line passes through, and it has the given slope. All right, so it allows me to work from my starting point not being locked to the y-axis, right? I can actually have a starting point anywhere on the grid. It could have been over here, it could have been over there, or it could have been over there. Anywhere on the grid, I could have had a starting point for my equation. And so this form is like the ultimate form. It is Charizard, my friends. You want to have this Charizard form. It's amazing. It's amazing, right? So a linear equation is written in the form y minus y1 equals m parentheses x minus x1. Parentheses are important here. Is in point slope form. Why? Because in that form, the slope can immediately be seen. It's the number in front of the parentheses. And a point can be determined where it is the, oh, that's interesting, it's the opposite of the number with the x and the opposite of the number with the y. All right, point slope form. It's going to be great. It's gonna be great. And so this is just gonna be so macro helpful for us, friends. All right, let's do this. All right, all right. Actually, I'm gonna scroll up just a tad. Ready? Watch this. No, that was more than a tad. Okay. All right, write an equation in point slope form of the line that passes through the point -8, 3 and has a slope of 1/4. So this is my x1, here's my y1, here's my m equals 1/4, and I'm simply going to like plug this in up here, and this one in right here, and this one in right there. Okay? I've just got my like Cthulhu tentacles all just like grabbing that point slope form, put my 3 significant facts in there. Oh, this is going to be great. So this will be y minus y1. y1 was 3, so y minus 3 equals m, so that's 1/4, parentheses x minus x1, and x1 was -8. So minus a -8 is the same as +8. All right, so I'm going to write this as +8. And here is my equation in, exactly, but it's minus a -8. Just like this, it looks like it says -3, which it does, but this was a +3. So these are always end up becoming the, it's the opposite for the point. Opposite and the opposite. Right, for both of those ones when I'm looking at these. All right, so point slope form. Let's do 2 more real rapid fast. I don't know, Charizard probably does not have a quick attack. I imagine he's less of like a quick Pokemon and more of like a damage dealer. I don't know. You know, like Pikachu, he's got quick attack. Here we go. All right, but we'll do these ones quick. So I've got a point and the slope. Hey, point-slope form. That sounds great. X1, Y1. I'll label this one over here too. And my M is...
It's like the most popular Pokemon. Like,
Pikachu or Charizard? Okay, yeah, absolutely.
even though, like, no one ever, like...
Yeah, I think it's because he was just like, you know, the TV show character and probably from that. But yeah, Everett, Pikachu is his favorite. I think it's just because of the TV show, though. Here we go. Let's see. So plug it in. Y minus Y1. Y1 is -1 here. So that's going to be Y plus 1 equals M. So M is -2. Parentheses X minus X1. 3 is positive, but this is X minus X1, so it's going to be X minus 3. Point slope form. Point slope form. Hey, hey. There we go. Hip, hip. Hooray. All right, let's do another one here. Y minus Y1, so that's Y minus 0 equals M, so that's -2/3, parentheses, X minus X1, so that's X minus 4. All right, point slope form. Y minus 0, by the way, you could have written as Y equals -2/3, parentheses, X minus 4, but in some cases, I actually kind of like this better, so it's more obvious that it's in the Y minus Y1 form, but because like this one almost looks like it was halfway towards slope-intercept, you know, like I would just have to distribute that -2/3, which, by the way, what operation is happening between this fraction and the parenthesis? What is this, like addition here? What's happening here? If you had to pick, like, is this addition, subtraction, multiplication, division? -2/3 is doing what to this set of parentheses? Being multiplied, right? This is being multiplied. When it's not written, it is still implied that it's multiplied. Meh. Meh. Meh.
I get confused on how you're changing the size.
Just remember that it's the opposite. Like, actually even like write that down, right? Like I wrote opposite for those two arrows, right? Somewhere write that down, that for the X and the Y coordinates, the X1, Y1, it's the opposite of those numbers. This is how it works out. Let's see, here's a little trick. You guys already have this on your paper. It says when you are given 2 points on a line, you can write an equation of the line using the following steps. So if I'm given 2 points, the first thing I do is find the slope using slope formula. So that's the M equals the Y2 minus Y1 over X2 minus X1, okay? Step 1, find the slope. And then step 2, use the slope and one of the points, so that's either one, I want to point out, to write the equation in point slope form. And point slope form is Y minus Y1 equals M parentheses X minus X1.
So, it doesn't matter which way, like, if you pick Y1 minus Y2.
As long as, you're referring to this?
Yeah.
If I do Y1 minus Y2, that works as long as on the bottom I did X1 minus X2.
Yeah.
So I have to like commit one way or another. Like so I can't flip-flop them, but if I flip both of them, then it'll be okay.
Then we did Y1 minus Y2.
Yeah, that's fine. Yeah, perfectly fine. You could even write it that way and I would be fine with it. Let's see, using 2 points to write an equation. So here's my 2 points. It says write an equation. Oh, what? That's interesting. They switched it up for us. Slope-intercept form. Let's start with point slope form. All right, temporarily, let's do point slope. Okay? So let's first find the slope. Let's label this X1, Y1, X2, Y2. And so to find the slope of my line, M equals, let's do Y2 is -2, minus Y1 over x2 is 3 minus x1 is 1. That's going to be negative 4 over 3 minus 2 is 2. What's my m? Simplify to b. M equals negative 4 divided by 2. What's that? 4 divided by 2 is 2, and then it's still negative. We also could have found that, I want to point out, since we had a graph, I could have also realized it's going down 2 over 1, down 2 over 1. So the slope was, in fact, negative 2. So I've got my slope, and I actually have 2 points. 2 points. So let's write our equation in point-slope form. So I could write y minus y1 equals m times parentheses, right, x minus x1. So here's point-slope form. But, or I could have written this. Check this out. Y minus negative 2. I could have used this as my point. Right? I can actually use either point in point-slope form. So let's do y minus negative 2. So that's y plus 2 equals, the slope is always the same, negative 2. Parentheses, x minus 3, the x. There. Both of these equations are right. Both of them will work. They give the same exact line because both of them will tell me a point that the line passes through and the slope of that line. And both of those points are on the same line. Now, suppose I want to convert to slope-intercept form. Okay? It's easy to write these equations in point-slope form when I just take a point and plug it in. All right, actually, I'm going to draw some arrows. This point we plugged in for this equation, and this point we plugged in to get that equation. But those equations are actually equivalent equations. If I simplify them, they'll both become the same thing. And it's actually easy to convert from one of these to slope-intercept form. Let's take the first one. Y minus 2 equals negative 2 parentheses x minus 1. To convert to slope-intercept form, all you do is solve for y. Okay? Watch this. Watch this. I'll distribute over here to simplify. So I'll have y minus 2 equals, let's see, negative 2 times x is negative 2x. Negative 2 times negative 1 is plus 2. How could I get y by itself? Y is being subtracted by 2. How do I move that minus 2? Add 2 to both sides of the equal sign, right? So I'll write this underneath this plus 2 over here, because those are like terms. And I get y equals negative 2x plus 4. Hey, slope-intercept form. But you notice in slope-intercept form, the slope is still negative 2. What's the y-intercept? What's b in this form? 4. Guys, check this out. Do you think this line has a slope, a y-intercept rather, at 4? Let's find out. Let me scroll up. Oh, do you think it does? I think it does. If this continued, it would have hit at 4. Yeah. Interesting. Interesting, right? Here was 3. Yeah, I didn't draw that quite to scale, but it does. Also, just to prove to you that our 2 point slope form equations were the same, what if I, in a parallel dimension, chose to convert the other equation into slope-intercept form? Let me just do that, just for proofsies. And I think this will be the last problem we do. We'll do the, I'm going to break this lesson into 2 days.
Remember the one that I'm really going with
Oh, my apologies. All right. Yeah, my bad then. Ooh. All right, yeah. This will be the last one we do today. So so check this out. I took the other point slope form equation. All right, completely different equation, but it's going to give me the same result. Let's see what this one looks like when I convert to slope-intercept form, which the way I do that is solve for y, right? Get the y by itself. Distribute the -2. Let's see, y plus 2 equals -2x. What's -2 times -3? Negative times a negative is positive. 6, yeah. 2 times 3 is 6. All right, how do I solve for y? What do I do to get y by itself?
Okay.
Subtract the 2, both sides. Guys, look at this.
y equals -2x.
It's the same. It's the same, friends. Notice that. Same. Wow. So both of those equations in point slope form represent the same line. Okay? And the convenient thing about point slope form is it's more powerful than slope intercept, because the only point that slope intercept form knows how to work with is a y-intercept, whereas point slope form can work with any point on the line. I could have even written a point slope form using this point. I could have written a point slope form using that point. You actually could even work with some of these weird fraction points. And you could have written an equation using the slope and then an x coordinate and a y coordinate, and it all works out. All right, thanks for watching, internet friends. Part 2 will be coming next week.